base formula. So if I want to determine log base 3 of 8, I don't know what this number is, so I'm going to write it's a number y. But this is equivalent to, this is a log equation. I want to present something before I do this. This is log equation. Any log equation can be, this is a double equivalency. It means this implies this, and this implies this. Can anyone refresh our memory? How do I change this log equation to an exponential? We start with the base, and we go counterclockwise. Base raised to y equals 8. So 3 raised to y equals 8. And this is an exponential equation. This is really the most important equivalency. Any log equation can be changed into an exponential. Any exponential can be changed into a log. So now I need this for later. And now we're going to use the change of base formula. So if I want to determine log base 3 of 8, I want to find a number that I raise 3 to get 8. So if you ask me what number do I raise 3 to get 8, I'll have no clue. I can't tell you what it is. I know it's less than 2 because 3 squared will be 9. But I have no idea what it is. So I have to use a calculator for this. So here's how we do it. We have two options because the calculator has log, which is common log, and it also has ln, which is natural log. One option will be log 8 over log 3. This is not log of 8 over 3. This is log of 8 over log of 3. Another option will be natural log 8 over natural log 3. So with the graphing calculator, let's punch in this. Clear if you have anything else in there. So it's either log 8 divided by log 3. The same answer will be obtained with natural log 8 divided by natural log 3, of course. So a function is 1 to 1. I can find two numbers that I raise 3 to get 8, just one. Only this number. How do I check my work? I'll go to 3 raised to which power? Whatever. Yes, I'm going to just say second an entry. No, I didn't mean that. I want 3 caret second an answer. I want the calculator to copy everything, not truncate it. And what should I get as an answer when I hit enter? Of course, if I don't get 8, something is wrong. But if I copy 3 to power 1.89, I will not get 8. I will get very close, but not get 8. So I recall the previous answer because the calculator takes it all. It actually takes that before calculating, and it gives us the correct answer. Then now that this is wrong, it's not wrong, but it's an approximation. Very good question. So then, in the calculator, every time I'm asked to, and I don't have the option of a base, whatever I want, then I will be using this formula. So the top is from the number, always, and the bottom is from the previous base. Very good question. But this is the most important concept. Going back from a log to an exponential, from an exponential back to a log. Okay, so we want to graph f of x equals log base 2 of x. The domain of this function is not all real numbers. This is a function with restrictions. Because the exponential function, do you remember what it was the domain of the exponential? Negative infinity to 0, but the range was 0 to infinity. So now the log is the inverse of the exponential. And I have to reverse the domain and range. Exactly. These are reversed because they are inverses of each other. So that's why log can be only applied to numbers that are strictly greater than 0. So then the domain is 0 to infinity. Therefore, I have to plug in some numbers. And last time I said, okay, since the base is 2, let's use powers of 2, like 1/4, 1/2, 1, 2, 4. Very easy to do this by hand. So let's do this by hand for 1 or 2. Log base 2 of 1/4. I have no idea what it is, but I know that this is equivalent to. Can anyone dictate? We start with the base. 2 raised to which power is 1/4? And the answer will be, which power I have to raise 2 to get 1/4? Yes? Excellent. For the next one, log base 2 of 1/2. I have no idea, but I know that this is convertible into an exponential equation. Which one? Yes. 2 raised to which power is 1/2? -1. Log base 2 of 1. I have no idea, but I know that this converts into 2 raised to some power equals 1. That must be 0. And of course 1 and 2 and so on and so forth. Well, look at this. That will be the range, but this is the domain. So I have to determine this limit, and I have to determine this limit. We don't know limits with logs just yet. So I will give you the answer. This is -infinity, and this is +infinity. So let's graph the function. Well, let me ask you. 0, -1, -2, -3, -4, -5. Where am I going? -infinity. 0, 1, 2, 3, 4, 5. Where am I going? +infinity. Good. So here's the, I'm graphing, I'm plotting those points. 1/4 -2. 1/4 -2. 1/2 -1. 1, 0. 2, 1, and so on and so forth. So this is log base 2 of x. What can you say about this function? Always increasing. The derivative will always be positive. And the domain 0 to infinity. What is the inverse function of this function? What do you think? It's an exponent. It's an exponential function. Which one? It has to have the same base. So it must be the function we graphed last time, 2 to the x. They are inverses of each other, and they have to be symmetric with respect to y equals x. They are not symmetric in my graph, of course. They're not perfect, but they have to be symmetric. In the same way, we will determine the graph of the other shape with 1/2. And I will list the properties. So here's the graph of the other one with base 1/2. Log base 1/2 of x. When the base is less than 1, is the function increasing or decreasing?
Decreasing.
Perfect. When the base is greater than 1, the function is? So is its inverse, the exponential. So here is the inverse function. Can anyone give us the inverse function? Can anyone name it?
1/2 to the x.
Perfect. And this is a point that is 1, 1, 2, 2 on the line 1, 1, 2, 2, 3, 3, 4, 4. You can reverse it because this is y equals x. So if the function crosses y equals x at this point, the inverse function will cross at the same point, mandatory. So this is indeed 1/2 to the x. We graphed it last time. Again, the two graphs have to be symmetric with respect to this line because they are inverses of each other. My graphs are not perfect. Good. So 3 properties, just 3 properties that no other function has. Log applied to a product in any base. I used common log. Log applied to a ratio, and log applied to a power. Let's say x to the b power. Does anyone remember these 3 properties?
So
This is the plus. This is exactly. And this is, yes, it becomes a factor in front. B multiplied by log x. So this one is log x minus log y. And this one is log x plus, of course, minus log y. These are the properties that no other function has. Of course, this is the product rule. This is the quotient. And this is the power. Product rule, quotient rule, power rule. Okay, let's practice with some problems and then look at the last thing with the derivative. So let's also put in the derivative here. Can anyone refresh our memory on e to the x prime? The nicest, yes, the nicest. Well, what about e to u of x prime?
e to u of x times
U prime or f prime, correct. What about natural log x prime is 1 over x? No, this is new. These two we did last time, but this is new. Okay, and what about natural log of a function of x? A wild guess. 1 over u of x times? Exactly. Common sense. That's a chain rule. Okay, so on page 319, let's differentiate between 57 and 90. Please choose. 57 and 90.
62.
62 it is. On page 319. Let's do that. And then we'll choose word problems. Okay, ready? So let's take a look. 62. X to the 4th natural log x. Is that? Oh, minus. Okay. So it's x to the 4th. Y equals x to the 4th times natural log x minus 1/2 x squared. Is it?
Mm-hmm.
Perfect. Excellent. Good pick. We want to find y prime. This is a product. This is not. We have to use the product rule. 4x cubed times natural log x plus x to the 4th times natural log prime, which is perfect, minus plain x. Bring down 2, multiply by 1/2, and we get x. So we simplify. Nothing I can do here. There is nothing. 4x cubed natural log x. But x to the 4th divided by x will be x to the 3rd and minus x. And we cannot do anything else. Let's stop and see if you have questions.
Where did we get the minus the x under this?
I bring down the power, multiply by 1/2, I get 1 and x.
Okay,
Better?
yeah.
Perfect. I think we should choose another. For example, 84. And please choose one more after that. Any questions? If we look at 84, natural log of e to the x minus 2. E to the x minus 2. We want to differentiate. Can anyone tell us how to start?
E to the x.
Yes. E to the x minus 2. Yes?
E to the x.
1 over e to the x minus 2. We have to differentiate the outer function first. Times the inner function, which is prime.
E to the x.
That's it. So you can just write it like this. Do not try to simplify. It's not simplifiable. This is it. Now look at 78 if you'd like to work on that, or 86 or 88, and tell me yes or no. 78 looks good. Natural log of 7x squared plus 5x plus 2. X plus 2, correct. Good. Can anyone get us started on y prime?
So it would be 1 over
Yes?
7x squared plus 5x plus 2. And then we have to do the inside, so that's 14x plus 5.
Excellent. You can keep it as is, or you can rearrange it as this at the top and that at the bottom. Let's also do 86. Any questions? '86 has natural log to the third.
One over x cubed.
Careful.
Negative.
Careful. This is a function to the third power prime. A function to the third power prime. I don't even care what the function is. It's a function to the third prime. How do I differentiate that? 3f squared times 3f squared times
6f.
times
Don't you take what's inside?
correct. Forget about this. I just want the formula.
Times f.
Times
3f.
it's the chain rule, right? Don't scare me, please. Please don't scare me. Okay. Put it on your forehead, on your hand, on your palm. I don't know where. Okay. So then y prime is
3ln x squared times 1 over ln x squared or x cubed.
the inner function prime, natural log prime.
1 over x.
That's it. So this is 3 natural log x squared divided by x, right?
Yes.
Do we see it?
We're kind of yeah.
Do we see it or not? Yes?
Why are we dividing by x at the end?
We're not.
You were multiplying.
I'm multiplying this over 1 by this, and I can put it on one fraction because this is over 1. Okay, let's also look in that case at 88. 88 has natural log of 3x. And we want y prime.
So it's 1 over x, 1 over 1 times 1 over
Excellent.
x, 1 over 3x,
Yes, times
times
the inner function prime.
3.
That's it. Simplify, and we get 1 over x, natural log of 3x. So remember the chain rule one more time. The first outer function, the second outer function, and the innermost function. I have to differentiate the outer of this argument. I have to differentiate the inner of this argument. And then I have to differentiate the innermost. Do we see it? Okay, would you like to choose another, or can we look at, let's say, 92? Find the equation of the tangent line to the graph of such and such at x equals 1. Or 94. Find the equation of the tangent line to the graph of such and such at x equals 2. Which one? 92 it is. And we have the graph is y equals e to 2x. No, it's 3x actually, sorry. E to 3x times natural log 4x when x equals 1. So it says find the equation of the tangent line to the graph of this when x equals 1. First thing I need to determine is when x equals 1, how much is y? Because the equation of any line is y minus y1 equals the slope times x minus x1. And I only have x1. I don't have y1. But how do I determine y1? Plug it in. So when I plug in 1 in 4x, I get 4. So this will be natural log 4. When I plug in 1 here, I get e to the third. Well, I have to use a calculator. I can't do this by hand. So let's do that. So we have e to the third. Here's e. And power 3. And then times natural log 4. So the slope is very ugly. But I'm sorry, the y value is very ugly, but it is what it is. So I'm going to write 27.84. Good. So now I need to determine the slope. So I need to find this number. How do I find it? Very good. Let's find y prime. Careful, because this is a what? It's a what? Well, I want you to say a product, right? And you cannot differentiate unless you use the product rule. That's all I needed. Do we all see the product? Perfect. So y prime, first one, prime is 3x. I can change that.
Times e to the 3x. Right?
So let's go back to the rule. E to u prime is e to u times u prime. I can change the argument. So it's e to 3x times 3. Is that clear what I'm saying? Perfect. E to 3x times 3 times natural log 4x plus e to 3x times
Times
1 over
4x.
times
And then 4.
times 4. Okay, let's write the formula one more time here before we simplify this. So natural log of u of x, you gave me this a few minutes ago, is 1 over u of x times u prime of x. So natural log 4x prime is 1 over 4x times the inner function prime, which is 4. Is this better? Everyone? Yes? Okay, perfect. So now let's continue simplifying a little bit. So can we get anything out of it? Not really. So this is 3 e to 3x natural log 4x plus e to 3x divided by x. Okay, very nice. Not really, but anyway, we found the y prime. Now what? So I know now that this is 27.84.
You need to plug 1 into the derivative.
Absolutely, to
and
determine
that's
this.
the slope.
Exactly, awesome, well done. So now when x equals 1. So this will be again 3 e to the third times natural log 4 plus e to the third divided by 1 is e to the third. With the graphing calculator, let's punch this in. So I'm just copying the first number because it's the same thing, just multiply by 3. That's out of laziness. So I have 3 times e to the third plus natural log times natural log 4. And now I want plus e to the third. And I want the number. So the slope is even uglier. So this is 103.62. So then, therefore, the equation of the line, the tangent line to the graph of the given function, it will be y minus 27.84 equals 103.62, x minus 1. And yes, we have to solve for y. So we have y equals 103.62x minus 103.62 and plus 27.84. 103.62x minus, this is an 8, this is a 7, and this is a 5, and this is a 7. Correct me if I'm wrong. Final step before we start reviewing. Just let's look at some more problems. Let's see what we want to look at. We want to look at, there are so many here. Acceptance of a new medicine. Forgetting. Walking speed. Forgetting again. What would you be interested in?
Medicine.
Medicine, yes, of course, yes, of course. Acceptance of a new medicine. Problem 102 on page 320. Very good, good job. Let's read the problem. The percentage P of doctors who prescribe a certain new medicine is P of T, again 102. It's right here. P of T equals 100, 1 minus E raised to negative 0.2T, where T is time in months. So this is percentage. When we read a word problem, we take notes. Find P of 1 and P of 6. Find P prime of T. So let's find P of 1, part A, and P of 6. What will this represent? P of 1 and P of 6. It will be the percentage.
After 1 month and 6 months.
Yes. So I like to put the function in the graphing calculator from the get-go. So go to y equals, and let's put in 100, parentheses, 1 minus e. Careful how you do this e thing. Parentheses, you know me already, negative 0.2x, there is no t in the problem, in the calculator. And then don't forget to close both parentheses, one for the top, for the power, and one for 1 minus e. So now we're going to plug in, I have to change second and table, sorry. 1 second. So we plug in 1, and we plug in 6. So a new medicine is introduced according to the model in the first month. What is the percentage of doctors who, according to the model, will prescribe it? 18.13%. What about after 6 months? And it kind of makes sense, right? You don't want to jump into it. You'll wait to see what happens. So if it's a good product, then 69.88% in 6 months. Excellent. Part B. Part B, find P prime of T. P prime of T. 100 stays outside. It's a constant. Inside, 1 prime is very good. Negative e to negative 0.2t times but negative,
Negative
right?
0.2, e.
Okay, let's look at the formula one more time. E to u prime is e to u times u prime. So e to this prime is e to itself times this prime.
Oh, so times negative 0.2.
Excellent. So negative 0.2 with minus in front will become positive times 100. That will be 20 e to negative 0.2t. So negative 0.2 times negative times 100. Part C. How many months will it take for 90% of doctors to prescribe the new medicine?
So we're just solving for 90%.
I'm not solving for 90%. You want to say you're replacing y by 90%, then we are solving for t.
Okay.
Good. So, yes. Perfect. What do you think we have to do first? Good. 9 over 10 equals 1 minus e to negative 0.2t. Next step. It's not fully cleaned up yet.
Subtract 1.
Yes. 9 minus 10 minus 1 equals 9 over 10 minus 1 equals a negative e to negative 0.2t. Excellent. Now I have to perform the operations on the left. Negative 1/10 in a moment, yes, equals negative e to negative 0.2t. I have to multiply both sides by negative 1. We cannot apply natural log to a negative number. 1 over 10 equals e to negative 0.2t. I can't. We have to apply natural log. Yes. And natural log e is how much? 1. Very good. Awesome. Great job. So natural log of 1/10 equals negative 0.2 t. I should write times natural log e, but this is 1. Only now I can solve for t. So how much is t from here?
Natural 4 to 10 over negative.
Perfect. Well done. Now question is, what what kind of number should I get? If I don't, I know something is wrong.
Negative?
Really?
Positive this time.
Exactly.
I don't think.
Thank you. Good. So, natural log of 1 divided by 10, close the parenthesis, and divide by, in parentheses, please, negative 0.2. Close the parenthesis for the denominator. So, approximately in how many months, if the model is still correct, in how many months physicians are expected, assuming that there is no glitch with a product, and how many months or how many months later after the product was introduced and they are convinced according to the model that this is a good product, they will start prescribing it. Right, 11.5, or I'll say 12 months approximately. Very good. Okay, part D, last part here. They're asking us to find the limit as t approaches infinity. What does that mean from p of t when we say t approaches infinity? Time goes by with no limit, with no bound. P of t 100, 1 minus e to negative 0.2 t as t approaches infinity.
So is this finding in 100% when they're using it?
Absolutely. Because there is nothing more than 100%. But let's do this step by step. So, if t approaches infinity, where does this go? No matter what this number is, doesn't matter. I'm multiplying by -1. So if this approaches infinity, multiplying by any number times -1 would be negative infinity. E to negative infinity is 1 over e to infinity, which approaches 0. Right? So this piece, so when t approaches infinity, negative 0.2 t will approach negative infinity, and e to negative 0.2 t, which is 1 over e to 0.2 t, will definitely approach 0. So this quantity approaches 0, this one. And of course, it can be more than 100%. So assuming that the product is still good, in the long run, the 100% of the doctors will start prescribing. Good. Okay, so one more word problem, and we can go back to any other type of problem from growth models. Just one problem, I promise, from the last section 3.3. More applications of the same kind. Growth models. So let's read. Let's choose on page 335. Okay, are we interested in human population? Are we interested in tortoise population? Say it again. Help me. Tortoise. Thank you. Tortoise population. Sorry. Oh, look at the spread of infection. 47. Diffusion of information. 48. Spread of a rumor. 49.
Infection or tortoises?
Tortoises. Thank you. Okay, let's start with the for spread on infection, and then we'll look at tortoises. Thank you. Well, I can't even come up with a word in this class. Okay, so 47 on 335. Spread by skin-to-skin contact or via shared towels or clothing. Methicillin-resistant Staphylococcus aureus, I think, MRSA. That's huge. We know about this. We've read about it, I'm sure. Can easily infect growing numbers of students at a university. See, that's why I had to get away from that situation. I knew it. Left unchecked, the number of cases of MRSA on a university campus, T weeks after the first 9 cases occur, can be modeled by. So one more time, this N is the number of cases. Number of cases. And T is weeks. Time in weeks. N of T. 568.803. I see a dot in there. Is it a comma or a dot? I see a dot. Over 1 plus 62.2 E2 negative 0.092T. 0.092T. You don't have to memorize this, but this is called a logistic growth model. Logistic growth model. Okay, let's see what they want. Find the number of infected students beyond the first 9 cases, meaning after 9 weeks, after 3 weeks, 40 weeks, and 80 weeks. You know I'm not going to perform these calculations by hand. I'm going to go to y equals. I'm going to put this in. I'm going to delete what I had. Since the top has only one number, we can get away without parentheses. 568.803. But now we can't. Divided by parentheses, please. 1 plus 62.2. And now E, careful with E. It has a power. I will put in parentheses, negative 0.092x. Close the parenthesis for the power. Come down and close the parenthesis for the denominator. And they're asking us for 3, 40, and 80 weeks. Second and table. 3. Really? What did I do? What did I do? Ah, sure. I see. I put another dot instead of a 0. Good. Thank you. So second and table, we want 3, we want 40, and we want 80. So N of 3. N of 3. I would personally, because we're talking about people, I would not round it up. I would say just 11 students. How can I have 11.8? Yeah, I would not. Yeah. 221. And N of 80 after 80 weeks, 547. Okay, part B. Find the rate at which the disease is spreading after 20 weeks. Find the rate at which the disease is spreading after 20 weeks. Say it again.
Is it finding in her?
Yes, excellent. So N of T, I would recommend we write it in the following way. 568.803 in parentheses 1 plus 62.2 e to negative 0.092t to which power? Excellent. I think this is easier, changing it into a product from a ratio.